Hello students and welcome back. Today we begin our last chapter in this algebra course, which is chapter 6. And so we begin by looking at the first section in chapter 6, which is section 6.1, entitled The Fundamental Property of Rational Expressions, section 6.1. Okay, let's start by beginning what exactly a rational expression is. A rational expression, in short, is any ratio of polynomials. So rational expressions, they are ratios of polynomials. Ratios of polynomials. And remember, a ratio is the same thing as a quotient. So it's like having one polynomial divided by another polynomial. Let's take a look at some examples. Some examples would be things like this. You could have something like 3x plus 5 over x cubed minus 2x squared plus 7. This is one example of a ratio of two polynomials. You could also have simpler expressions like simply 1 over x. That is also a ratio of polynomials. And you could have something like y minus 5 over 3. Things like this too. So these are all examples of rational expressions. Now they look similar to fractions, except they have variables involved, and in fact you treat them just like fractions. You can reduce them, you can add them, subtract them, multiply them, and divide them. So we're going to take a look at section 6.1, which is, first of all, we're going to reduce rational expressions. So that's the first topic. So let's reduce to lowest terms, rational expressions. Now to do this, I want you to recall how you reduce fractions to lowest terms. We'll look at an example, and this will be example A, and this is something we've all seen before, okay? Let's reduce the fraction 9/12 to lowest terms. Well, right away, you might come up with the answer 9/12 reduces to 3/4. I'm going to go about it a little longer way. I'm going to say, okay, you're looking for a number that is divisible, or a number which divides into both 9 and 12. 3 works, because 3 times 3 is 9, and 3 times 4 is 12. And we know that 3 over 3, or 3 divided by 3 is 1. It can cancel out. Whenever you have a common factor in the numerator and denominator, you cancel it out. And so 9/12 is simply 3/4. Okay, that was reducing a fraction to lowest terms. Now let's use that same idea, or that same principle, to do rational expressions. But before I actually give an example, let me pull up on font the basic property that I'm using when I do reducing of fractions or reducing of rational expressions. This is called the fundamental property of rational expressions, and it says that if you have a times some factor k divided by b times some factor k, you can cancel the k and you're left with simply a over b. And I just have one more stipulation there, you might see. That is, b and k cannot be equal to 0 because you can't have a denominator of any fraction equal to 0. Okay, let's use that fundamental property and now do a couple more rational expressions. We're going to reduce them to lowest terms. So let's look at example B. Let's take 24a cubed, 24a cubed, or a to the third power, over 18 a squared b. 24a cubed over 18a squared b. And let's reduce this to lowest terms. First thing you want to do is you want to work with your numbers and think, what's the biggest number that will divide into 24 and 18? And that is 6, right? You can reduce 24. 24 is actually 6 times 4. 18 is actually 6 times 3. So you're going to be able to cancel the 6 out. Then you have your letters to worry about. A cubed, well, a cubed is a times a times a. A squared is a times a, and then you have your b. And what can you cancel? You can cancel any factors that are common to the numerator and the denominator. We're going to cancel here the 6. We can also cancel an a. We can also cancel one more a. And what does that leave us with? On the top, that leaves us with 1 times 4 times 1 times 1 times a, or simply 4a on the top. And on the bottom, or the denominator, you have 3 times b times 1, which is just 3b. And therefore, you've reduced the rational expression 24a cubed over 18a squared times b to be 4a over 3b. Okay, let's take a look at a little more complicated rational expression now. Let's take the rational expression, which is a product of x plus 1 and x minus 2 all over x plus 1. Now this is interesting, but notice what you have is just like previous examples, you have a product of two things over something else. Whoops, I hit it there. Now what can you cancel? You can cancel any factor that occurs in both the numerator and the denominator, and if you look, the x plus 1 clearly occurs in both places, so I can divide x plus 1 by x plus 1 and get 1, and that leaves me simply with x minus 2 over 1, or just x minus 2. So you could put x minus 2 over 1, but we know that whenever you have a 1 in the denominator of the fraction, that's the same thing as just x minus 2. And so you've reduced that rational expression to be that. Okay, let's take a look at some more. Let's look at example D now. Example D is going to be the polynomial 6x plus 10, no, excuse me, it'll be 2x plus 10 over 2x minus 8. 2x plus 10 over 2x minus 8. Now, what you're really tempted to do is you're tempted to cancel out the 2x because it appears in both places, but you can't do that. And the reason is because 2x is not a factor. 2x is not being multiplied by 10, it's being added to 10. The only time you can cancel things, and let me go back over here, is when you have multiplication involved. That's the only time you can cancel things, is when things are being multiplied together. So, in order to cancel anything, I first of all have to write this as a product. Well, this is where factoring comes in. You're going to factor both the numerator and the denominator, and therefore you'll have a product, and then you can cancel anything that looks alike or identical in the numerator and denominator. So let's factor. On the top, if you have 2x plus 10, you want to take out a 2, and then you're left with x plus 5. Okay? In the denominator, you can also factor out a 2. And when you take out a 2 from the bottom, you're left with x minus 4. I now have a product in the numerator and I have a product in the denominator, and now I can cancel anything that occurs in both places. And this time, notice the 2 occurs both places. And again, because it's a product, I can cancel it. The x plus 5 and the x minus 4 are not the same terms, so I can't cancel those. So I'm simply going to write my answer as x plus 5 over x minus 4. Okay? So the key is, when you have rational expressions, to reduce them, you always want to factor first and get products. Let's do a couple more. Okay, let's look at example E. Let's do t squared minus 25, t squared minus 25 over t squared plus t minus 20. Okay. Again, you might be tempted to cancel t squareds, but you can't do that because you don't have a product in the numerator and the denominator yet. So let's factor first and make a product. T squared minus 25, you should be getting good at this now. This is simply difference of squares. This factors as t minus 5 times t plus 5. Double check. T squared minus 25, that factors as t minus 5 times t plus 5. On the bottom, you have a trinomial. You need two numbers that multiply to negative 20, but add to 1. And I think that'll be t plus 5, t minus 4. That works. T plus 5 times t minus 4 gives us the bottom polynomial. You now have a product here and a product here, and now you can cancel anything that looks identical. Looking at it, you could say t plus 5 is the same in both cases, so we'll cancel that out. But you can't cancel the t minus 5 and t minus 4 because they look different. So let's just write t minus 5 over t minus 4. And that's your final answer right there, reduced to lowest terms. Okay? Let's take a look at a tricky one now. Let's look at f. And f is 2 minus x over x minus 2. 2 minus x over x minus 2. Now they look really similar. And in fact, you might be fooled. They look pretty much the same, but they're not quite. Here it's 2 minus x, and this one is x minus 2. Well, let's compare. Let's actually rewrite the top with the x being first. So if I have 2 minus x, that's actually minus x plus 2, right? That's a minus x plus 2. And on the bottom, here I have an x minus 2. So they're really not the same expression. Can you factor anything? Well, let's try to take a negative 1 out of the numerator. Let's factor out a negative 1. Okay? And when you take a negative 1 out of the numerator, you get x minus 2. Let's double check. Negative 1 times x is negative x. Negative 1 times negative 2 is positive 2. And so therefore, that's the factorization for negative x plus 2. Well, why did I do that? Because look, the bottom is just x minus 2. And in fact, now x minus 2 appears both places. And you can cancel it. And therefore, it leaves you with simply negative 1 as your answer. And that's actually a rule that you want to get used to looking at. Whenever you have subtraction where the terms are reversed order, 2 minus x, x minus 2, whenever you reduce this expression to lowest terms, you will always get negative 1. And that's just kind of a little rule you want to keep in mind. That's your introduction to rational expressions. That's the end of section 6.1, so I'll see you next time.